Hello, hello, and good evening. Does this thing work? Yes, it seems to work, at least I think I can hear myself. So, welcome everyone, and today we are going to start on time, and today I'm not going to do any news or any shoutouts. The shoutouts actually moved to the, to the nice rotating feed bar. And the idea is basically to save some time. One thing I will note is that there is no mission today either. My apologies for it. Actually, the agent 1336 managed to solve their mission without external help, or at least that's the best excuse I've heard for why there is no mission today. So I will try to make one for next week. Actually, the reason there is no mission is I was too busy finalizing the Gunveil's Summer Game Dev Challenge. The results are on my blog, so if you care about it, do check it out. There are also some videos on my channel from the games. So that's it, and now let's move to today's topic. Today's topic is about making a simple packer or protector for executable files. So basically it's like this. That's one of the most basic concepts in reverse engineering, or actually anti-reverse engineering, and not only but it's somewhat related to it, is trying to wrap the executable in a mechanism which makes it unreadable. The most basic idea is basically to prevent a simply disassembling the executable, and the idea is to obfuscate the code in some way as a whole, basically, not like individual instructions or anything, but like taking the code as a whole, obfuscating it, and therefore making it unreadable for the disassembler, at least parts of the code. So and the idea is to make it in a universal way that basically you can use on any application, not really application specific, so you're not making it inside one application, but you're doing a program which can be used to do this for any application you choose. And that's actually what's called a packer or a protector. And there are quite a lot of packers and protectors out there, and I mean a lot. When I was working for an antivirus company, I guess like 10 years ago, 11 years ago, something like that, I was making static unpackers for this kind of protectors. A static unpacker is basically an application which grabs such a executable file which is protected by or wrapped using such a packer or protector, and it tries to somehow like unwrap it and get what was inside the original executable, or whatever is closest to the original executable, out of there and put it in a separate file. And it's called a static unpacker because it doesn't run the executable itself. It might do some emulation of some parts, sometimes it was required and unavoidable, but in general it would not run the executable on the native system. So apart from that, there are also dynamic unpackers, which basically just run the application, wait until it unpacks in memory, because the CPU cannot execute encrypted code. So in the end, it does have to actually, you have to decrypt or decode the code so it's readable for the CPU somewhere in memory, and therefore, well, you can basically grab the code after it self-unpacks after executing the executable. It's kind of risky, right? Because you don't know what you're executing. Actually, that's why antiviruses back in the days didn't use dynamic unpackers, they used static unpackers. And but a dynamic unpacker, basically, the most basic one would be like executing like several instructions and placing memory breakpoint on the stack previously to what was executed, and then waiting for the stack pointer to return there, and that was basically a signal that probably it already unpacked and probably it's ready to be dumped onto a disk and to form a new executable file. There are also, of course, like ways to prevent automatic unpacking, or try to prevent, and ways to prevention of automatic unpacking and so on, but we are not going to go there today. I'm also not going to talk about similar ideas where you, for example, pack pieces of the code, like each function separately, and then when you want to execute a function, you unpack just this function, and then basically execute it, and then you repack it when leaving the function. So in memory you always have only a call stack worth of functions, like 1 to 5 functions which are unpacked, and everything else is encrypted in some way. Obviously the keys need to be there, the keys need to be in memory or the algorithm to the code, so it's not really cryptography, it's just obfuscation in the end. And yeah, that's basically so the question is something like my ROP program reverse engineering challenge. No, actually like my Python rare and reverse engineering challenge. That's where I basically used that. There was a guy at DEF CON in Black Hat who made a compiler that changes all of the code into move operations. Yes, that kind of thing, obfuscation, was actually on 2 CTFs. I did work on one of such challenges on Playing with Dragon Sector. We actually both with Yuru did one, and a side channel attack on that actually worked really well, and we managed to solve it. Surprisingly, the move obfuscator or move obfuscator, I have no idea how to pronounce it, sorry, is if you're into electronics, that like basically have really similar ideas to sometimes what they sometimes do with like read-only memory there to store some values. But we're not going to talk about the move obfuscator today. We are going to move into, well, creating a simple packer for static ELF files, 64-bit. Because, you know, it's 2017, so let's not do it for 32-bit, let's focus on 64-bit. Yeah, ELF specification is the first thing I'm actually interested in, because and this is going to be funny, because I somewhat know the ELF format, but I don't know it by heart. For example, I do know the portable executable format by heart. But by heart, I could well, just out of my memory, probably recall all the structures and the names. I cannot do it for ELF. I'm also going to look for Korkami ELF 101, because that usually helps a lot. I'm a person who likes, you know, images and graphs and posters, for example, and Anja Albertini has usually a lot of them, so let me find them for Anja. Where do you have your binary posters? Perfect. ELF executable. Yeah, here we go. It's probably going to be, well, that's okay, that will work. 32-bit though, so, well, whatever. It still shows us basically the basic structure, right? So the ELF, it has like an ELF header, then there is also a program header, then there are segments, and after the segments there are also sections. I'm going to basically be using segments today, not sections, but we'll get to that in a second. I guess this is all I really need. I guess I can give you a link to this. Yeah, and a link to the ELF format specification. Also, please let me know if you can hear me correctly, because I actually tweaked my microphone setting versus the last time, so it should be a little better today. I'm not sure if it actually is, but, well, I did some video recording during the weekend and it worked rather fine, though it was a little differently placed, because I currently have my microphone here, like exactly next to my finger, just off the screen. Cool. I'm also going to be using Python today to do the packing, because why not? Yeah, so I'll create packer.py, and the size of the font is okay today, surprisingly. So that's one thing. The other thing, I'm actually need basic program I'm going to pack. So I'm going to do it for one program. Usually when you create a packer, you are using, you basically have to test it a lot, because it's not a trivial thing to do. It's trivial, the concept is trivial, but it's all boils down to the edge cases, and I would like not to handle edge cases today. So I'm just going to make a trivial packer which handles the most basic ELF file and only one file. So I will not test it on purpose on other files. But please keep in mind that if you would like to create a real packer, you do have to test it a lot, because it has a lot of edge cases. What are the differences between ELF and exa, like PE structure? The differences are basically in the structure names. The whole concept is super similar, with the exception that there are no segments in the PE files. In the ELF files there are segments and sections, in PE files there are only sections. The segments are basically way of telling the kernel how to structure the memory for the program you're loading, and the sections reside in the segments. But the kernel uses the segments to basically create a memory, like memory places, to allocate memory for the executable file. In PE, the sections are used for the same purpose, even though in the ELF file both the sections and segments could be used for it, the segments are used. So that's one difference, and the second difference is that import files and imports are treated totally differently in both cases. But yeah, let's maybe not go there today, especially on Linux, but it's done in user land, like the loading of the imports, and it's not part of the kernel, it's part of the glibc, which is quite surprising. On Windows, it's part of the PE loader. There are, of course, a lot of minor differences as well all around, and again, all the structures are called differently, but when you go on a really high abstraction level, in the end, it's a really similar concept. So there are two questions. For faster performance, does move obfuscator or moveFuscator make any difference, like some hardware tweaks not working? I actually don't know. I didn't play with it too much, so I don't know how well it handles different instructions, and how does it implement all the instructions. So I'm not sure I can answer your question. I guess you can email the author or read the paper or look into it to check it out. Okay, and I did answer already the question about ELF and PE. Why does everyone use this editor Vim? The main reason I am using Vim is because it opens in 0.1 second, and I dislike waiting for a text editor to open. I just want to have it immediately and be able to type something, and that's the main reason I'm using Vim. You might laugh, but that's actually the truth. Okay, so this is the do I have what? Yeah, this is the main application I will be testing this on, and I will compile it with two options. First, this is not going to be a position independent executable, so no pi, because I don't want it to be moving around. That's also a case which needs to be handled in full-blown packers and protectors, but I don't want to be handling it today. And static, for making actually a static executable, and it's going to be a 64-bit executable. Yeah, let's do it like this. Now I need to compile it. What's my opinion on Sublime? I never used Sublime, so I have no opinion on it. And, oh right, sorry, too much Python. Thank you, dear supervisor. So that's one thing. And VS Code. I don't know what is VS Code. Is it like some Visual Studio thingy? I did use the Visual Studio editor, but it's slow. Okay, yeah, let's compile it. Now let's make sure everything is fine. So KrzaQ is a bash script which you can find on the internet, and I'm going to use it to see basically if the file has any funky stuff, but no pi, which is good. The rest I don't care about too much. Yeah, what's the size of it? Can I strip it? Let's strip it just for the sake of it. Stripping basically removes some sections which may contain some additional metadata. It doesn't change the core of the executable, so it's safe to do. And yeah, and you can, as you can see it, well, as I said, remove some stuff which is not really needed, but might help you during debugging. So this is Visual Studio Code. Yeah, so I never used it. I did play with Atom for some time. It was okay. Launched too slow. I did play with like Notepad++ and so on. And yeah, I mean, in the end, whatever works for you, right? Vim is okay for me. I'm sometimes looking at other editors because Vim is, in the end, somewhat limited. For example, even if you could like create some other windows and so on, you're limited to only this like text buffer thingy, and you cannot do proper graphics. For example, if I would like to create a plugin which displays like the code as a graph, I cannot do it. So yeah. So it has its limitations. I still like it for other reasons. So this is okay. Does it work? It works. I guess what I can do now is I can see it in IDA. You know, creating a packer is all about low-level stuff, and if you're doing low-level stuff, you probably want to see what you're doing. So let's just see it here. Okay, so there are quite a lot of sections. These are not segments, these are sections. As you can see, this is quite funny, and this is something you should pay attention to, especially on CTFs. That these sections are actually, these sections are read-only and executable. They are not writable, right? And then we have a section which is raw data, which basically, like this section ends. You can see the A to CAD address here, and this section basically begins with some minor padding, but it's still the same page. And IDA tells you that it's read-only, but there is no execution. You cannot execute code in it, and that's actually a lie, because, well, even though there is no executable argument here, well, it still has to be on the same page in memory, and on x86 the smallest page you can have is 4 kilobytes, and this is not a 4 kilobyte boundary, which means that at least the beginning of this section is still executable. So for example, you can look for return-oriented programming gadgets in that end of the section, because you can still execute code there. So yeah, my idea will be to basically grab the segment with, or the section of text, so only this section. I'm not going to touch any other section today, and well, encrypt the code with, I don't know, just XOR it or whatever. It doesn't really matter. I'm not going to do anything with the other sections. In case of creating a professional packer or professional protector, you obviously need to handle all the sections and encrypt them as best as you can. Which might be kind of tricky in some cases, but yeah. So I'll focus on this just for simplicity today. Now, I don't think there is a way, or at least I don't know a way how in IDA to basically display segments, but that doesn't really matter either. Now, what's important is that, or what I'm going to do from a like theoretical point of view, as you can see, the application basically begins execution here from this address, right? And this address is what's called EP, like entry point. Oh, I can actually type here, so let me type EP. Now, in terms of packers and protectors or reverse engineering, this is actually referred to as OEP, like original entry point. And the idea is that I'm going to change the EP, the real entry point, to point to some other address, to my code, my shell code. And my shell code will be, when executed, when this application is executed, it will first decode the code, because the code will be in an encoded form, and then so yeah, this will be like decoded, all of it obviously, up to the end of a section, and then I will jump to the OEP, which is the original entry point, and at that point the code will resume normal execution from this point, like basically nothing happened. The idea is that this code cannot be aware that some other code executed before it. The environment has to be identical, but that's rather easy to do, because in this case the environment is basically what's on the stack further away from the stack pointer, and also all the other registers. So if we have a stack pointer here and it points, well, it actually grows this direction, we can overwrite anything on the stack here, because the application cannot assume that this part is zeroed anyway, so we can overwrite stuff here. And the idea is basically for our code to first dump all the registers to the stack, then do what it's supposed to do, which is unpack the code, then restore the registers from the stack back to the register banks, and in the end, jump here. Yeah. So that's the idea basically, and I need to create a Python script which basically encodes this section. This is encoded, encrypted, for example, but again, this is more obfuscation than actual encryption because the key has to be verb, key has to be placed in the executable, or at least the algorithm with key derivation has to be placed there. And so Python has to locate where the section is, then encrypt it, and then inject a somewhere. The somewhere is the funny thing here. My shellcode, redirect the EP, store the original entry point somewhere, save the executable, and that's basically it. So that's the idea. Let's try to get to it. Why use the stack for dynamic memory allocation? I'm not sure what do you mean? I mean, that's not really... I wouldn't call using the stack dynamic memory allocation, in all honesty. Is the entry point every time in the text section? No, but as I mentioned, I am not going to... It doesn't matter for our case, actually, where the entry point is, because we don't jump to the beginning of the text section, we jump to the original entry point, whatever it was. So we don't care, and it's not always in the text section, I believe. It's the convention basically says to place it in the text section, but it can be anywhere in the file in an executable place. Or in some cases, even not in the executable space. Yeah. Cool, so we have this. I'm going to close it because this is no longer needed, and this is basically my packer. So let's import some basic stuff which I'm going to use today. So from struct I'm going to be using unpack and probably pack as well. I'm not sure if I need anything else today, but yeah, let's just import these two things. They might be useful at some point. Okay. Wrong language. Let's do this. Yeah, like basic Python boilerplate code. Okay, and I guess let's do it like this. So this is fine. There's a question. Where in episode 17 on your Polish... Where is episode 17 on my Polish channel? Was it deleted or what? That's an excellent question. I have absolutely no idea what episode 17 was. I'm actually curious enough to check now. PL episode 17. I don't know. Maybe there was no episode 17 and it's just, you know, a mistake in the... in how we counted when, like, the episodes, basically. It's pretty possible that there was never any episode 17, that we jumped from like 16 to 18 by my mistake. So I don't know. I didn't delete any episodes, so that's probably the most probable answer. We should investigate. Okay. Cool. So let's now, I don't know, I'm going to just check it if it works. So I'm going to add the shebang with not bash, user bin Python, of course, and I'm going to change the file format to set file format to Unix because I'm writing on Windows, so it uses the Windows end of lines, and Linux kernel dislikes having the Windows ending here. So that's fine. Now I need to actually chmod executable my script, And this will probably want to reload it. No, you don't want to reload it, that's okay. Oh, it's executable anyway, so never mind. Because I'm on, as you can see, I'm on a VirtualBox partition anyway. Yeah, seems to work. So now let's assume that I want at least one argument, and the argument is going to be the executable name. So yeah, again, like boilerplate stuff. I never remember the format for Python's arguments. Okay. So if len argv isn't equal to 2, then just return -1 and say, hold on, maybe usage. Okay, this looks fine. So now, first we need to load it in memory, so yeah, let's go to elf. Elf is supposed to be equal to, no, let's do it properly, with open argv1 yeah, let's just read it. Do I need to do, let's do a byte array here. Do I want a byte array? I'm not sure I want a byte array. I might change it later on. Okay, so now now I have the elf in memory, and in the end I'm going to store it somewhere. So let me create the name in a rather nasty way, like just adding packed as the extension, or a second extension in case it already has one. I'm going to write elf. I'm probably going to change this later. Changes. Cool. So now we have a copying program. Why do I use coding in the Vim instead of Paint? That's an excellent question. Yeah, it's just because I'm not sure what kind of color palette you should use for implementing the elf format. Now in the elf format itself, I'm not going to do a proper elf parser because, well, you know, 1.5 hour stream, right? What I'm going to do is I'm going to basically jump into the structures, like find the structure which I need as fast as possible, and work from that. So what do I need? I probably don't really need the elf header. I'm not going to check if the elf is like a correct elf file, if it's really a 64-bit x86 file. I'm going to skip it, and I'm going to assume it actually is. So this is the elf header. Now I need a 64-bit elf header. I'm pretty sure they vary somehow. And I need to get both the section table and the... Sorry, is this like... do I have... yeah, elf 64. I don't know, let's check this, I need something really elf specific, 64-bit specific, because the lengths of the section change, and sorry. So the first one is this, the file header, which I guess I should zoom. Do I need anything from this field? There is, oh, these two things are probably interesting. The program header offset and the section header offset. Having the section header offset already gives me the section headers, which contain information like, well, where this section is located in the file, as well in memory. And to find the, you know, the .text section, I actually need to parse it, so I do need to read at least this one, for starters. I'm probably going to need also the program header, because I think it contains the offset of the segment table. I might be lying, but we'll get to that later on. There's also like sizes, which I do probably need, and there's so it seems like the name of the sections are also placed there in the headers themselves, but I do need to grab them from the files. I'm going to read probably the whole structure anyway. Okay, there's supposed to be a question. Is that a different entry point address in the struct, or why do you need it? This one, I probably do need it. This is the original entry point for me, so I need to grab it as well. So for point, if that was your question. So yeah, I need to actually read this, parse this section, because there are quite a lot of important things here for me. So let's move this here, let's move this here. I guess we can see everything, perfect. So, unpack elf, I have no idea what the size is, I'm going to calculate it in a second. And, sorry, file header it's called, okay. So I think there's also a way for me to name the fields, but I never remember it. 16 bytes, 16s I think, or 16b. Python unpack struct format pad byte, no value, b is signed byte outside. Yeah, let's maybe do this. It should be fine. It should mean 16 bytes, I think. Yeah, 10c means 10 characters. I don't think you can see it here, but yeah, so this is the proper way to write it. Then we have 64 bits. I think the Q is the proper Q. Yeah, Q is an 8-bit unsigned integer, so this is what I'm looking for. How many Qs are there? There's like, no, this is half actually, sorry, my bad. I was looking at 64 instead of this. So half is, what's half? Half is 2, always 2, word is always 4, and x word or sx word is 8. Okay, perfect. So then we have, let me make it a little bigger. Okay. So we have 2 halves, then a word which is capital I, an address. Okay, what's an address? Probably the address is 8, yeah, as I thought. So address is going to be Q. I did check it, so that's Q. Then 2 offsets. Offset is probably 8 as well. Yeah, I'm not sure if it must be 8, because have you ever seen like an executable which is more than like 4 gigabytes? Actually maybe you have, because if I remember correctly, if you compile like CLang for 64-bit, it's actually 2 gigabytes, so that's already pretty close for comfort, so maybe let's not go there. Okay, address, 2 offsets, then a word which is I, and quite a lot of halves, which is 1, 2, 3, 4, 5, 6. H. Yeah. Okay. Now, what's the total size of it? It's actually going to throw a nice exception, telling what the size should be. Blah blah blah. 58. Perfect. 58. Yeah, it's here, as you can probably see. Okay, now it works. So let's see what it actually got for us. And these are the, yeah, this is the elf, like, you know, elf letters in ASCII. Well, that was not really helpful. Then we have some more not interesting stuff, but we really don't care about the interpretation here. What we do need is we basically need to, let's do it the proper way. So the proper way would be to actually give it a list of fields. I guess I can copy the fields. Maybe typing is faster. You can obviously use like some elf library to do this, but given that my live streams are somewhat low level always, I prefer to like show you that it's actually possible to parse this by hand. You don't have to use any libraries. But you can, if you like. Okay, now it's better. Now let's pick it up this way. This is not going to work, is it? Yeah. Why too many? Yeah, too many, because this actually... you know what, I'm going to do something like change this to S probably. Sorry, what is S? I think there is a way to actually tell it that I want 6 characters. The 10 byte string, so C. Oh, that should be fine. Sorry, there are some questions. Yeah, I could use some PwnDBG blob. Yeah, I could use libraries as I mentioned. Is this possible for any executable like .NET? Each executable format has a different format. That's why it's called an executable format, I guess. But yes, packing is in general possible for most things. Not sure if for .NET or Java, because the reason is that you need to actually unpack it in memory, like change the code in memory, decrypt the code in memory, and then execute it. If you can execute bytecode in .NET, then you can do it. If you cannot, then you cannot probably do it. For example, for Python, the bytecode is supposed to be read-only, but using some tricks, it's possible to do it. Well, like overwrite things in memory, like there is no tomorrow, basically. So I'm not sure about .NET, but in general, it should be possible. For 6 halves, I gave only 3. Yes, because I am stupid. Thank you. So this should be 64. Yeah, alright, perfect. Now it works. Thank you. Demons. So this works. Now what I need, for example, the address of this, or the offset of this was the offset library, 31. 31. Is this correct? I don't know if it's correct. Maybe I'm interpreting it wrong. I was actually expecting this to be offset. Oh, it's section name string table index. I don't know, maybe it's the index in the program header or something. I'm going to get to it later. Let's start with the entry point, I guess. So this, what's the entry point, and if it's the same thing which I see in IDA. It's 4009DO. I think that's the same as we saw in IDA, right? 4009DO, yes, that's the same thing, so this is fine. ABC says that you can do it in .NET, you can create and run code in the runtime. That's pretty cool. I know you can do it in, for example, in Flash, in, you know, ActionScript. Okay, sorry. So this is the first thing, the original entry point, right? So I'm going to note it down. And now, the section header offset, is it a real file offset or is it some index somewhere? Let's see. CDBFO, that actually sounds really reasonable. Let me open the file, the hello file in a hex editor. Here we go. Now let's jump there. Yeah, maybe, I don't know. Sorry, does this have a... Do I have a structure viewer? Select structure library. Is there ELF here? I don't have an ELF system for it. That's too bad, but this may be okay anyway. So I'm going to assume this offset is actually fine. And now I also need the number of section header entries, so this thing. And I guess I'm going to print it. And I'm going to check in IDA if it's correct. 32 sections, that's quite a lot that's typical for ELF files, though in PE executables there are usually like way less sections, unless you compare it with GCC. 32, that's quite funny because this says 25, but maybe there are some weird sections which are skippable or something. We'll get to it in a second. Let's try to look for the proper structure then for it. There are the descriptions of the fields. So, contains the number of entries, that's okay. Contains the file offset in bytes of the section header table. This is good news. Now, what is this? The index contains the section header table index of the section containing the names. If there is no section, then it's undefined. So there seems to be like a special section which actually contains the names of the sections. That's fine. So yeah, sections, blah blah blah. Oh, and there are special sections indeed. There is a processor specific use, blah blah blah. So I'm probably going to like not use any of these. But I do again need to implement the structure. So let's do it. I'm going to create a new function called like parse section, and it takes some data in, and it basically returns what does it return? Let's return the dictionary, shall we? Or maybe not a dictionary. Let's just do this. Unpack, and so there are 2 words, 1 X word, 1 address offset X word, 2 words, and 2 X words, so this should be fine. I have update data, obviously, and I'm going just to return it like this. So for I in range the number of section, so this do, and now I want to basically parse the section. So again, retyping. I could probably figure a way to copy it, but it probably would take me the same amount of time that I actually do to retype it. Sometimes I think that like programmers really, like one skill a programmer needs is some patience to basically do some stuff like this, like just retype 10 or 15 field names or something. Or like do similar stuff. So unpack, no, not unpack, parse section. Okay, let's move it here. I'm not sure this is like proper formatting, by the way. Yeah, let's do it like this. Okay, so parse section, and I need to pass it what? I don't know what's the size of the section, but that doesn't matter at this point. I need to pass it D from, starting from, D is my data, no, ELF is my data, my apologies. From ESH offset to ESH off, and I have absolutely no idea how many, so I'm going to give it to match. And let's see how it crashes, and it again will throw the exception. It says 64, so yeah, let's do it like this. 64, that's fine. I'm going to, just for the sake of it, put like 64 here as well. Cool. And now I'm going to see what's in SH name, but I already know, I guess it's written here, right? But it's the offset in bytes to the section name relative to the start of a section containing the name, yeah. Okay, so it says 0000. Am I in the right location? Oh, yeah, it's 000 because I actually messed up one thing. Here, I actually need to add some offset. And the offset is calculated like in a I times 64, where 64 is actually, it's, you know, sorry. Yeah, this 64 is the same as the 64s, is the size of this section. Can you actually see the code? Yes, I guess you can see the code. So yeah, let's do it again. Now this looks much better. So I guess I can also having this thing. Oh no, I first need to find the section which has the names. But so I guess I'm going to display a couple of things, but the most important thing for me is this, which is the type of the section. And the type of the section is 0774111 blah blah blah. Now, the types are in table 8, and the table 8 is here, which is sorry, what sections do I have again? So I have section 0. Section 0 marks an unused section. Why is there an unused section at the beginning? I don't know, but yeah. Then 7. 7 is a note. It contains information. It's a section which contains information. Perfect. Then we have relocation entries, which is quite weird because this isn't a relocatable executable, or at least it shouldn't be. Then we have section 1s, which are proc bits, contains, these are like real sections. And then we have section 8, no bits, contains uninitialized space. So that means in the file there is like, it contains no information, there is just metadata, but in memory it allows like to tell the kernel to allocate some memory for base and zero it. And I'm going to use it, for example, as the data section, uninitialize the data section. Then we have E. E is 14, and I don't see 14 here. Why is there no 14 here? No, seriously. I have no idea. I'm going to find it in a second, I guess. Yeah, this is 14, right? There is no 15 either, so that's weird. I do have 7. No, 7 I already had, and I do have 3. 3 is the string table. So the string table, as in the name of the sections, are actually in this last section here, which is quite funny. Now I have absolutely no idea why I have another section here, which is 3. No, this is fine. Okay, no, this is fine. Because I actually thought I had this. Yeah, perfect. So I guess I need to first find the section which is actually the text section. I guess I should like have a list of sections, and all this information I'm going to actually do something nasty. Please don't do it at home. So struct and sections and struct. Yeah. Now, yeah, I'm going to basically do it in 2 phases. How do they call it? The third tab. String table. Is this the string table I'm looking for? I'm not sure actually. Okay, but I did have a weird section named with a type 15. Why is it in publish? Section header. And they have, yeah, they do have E, which is like array of constructors. I guess you can see it. And F is array of destructors, which is like not really needed by the kernel. It's needed by the C library, I guess. Now, what's the description here about the string table? I guess the string table is what I'm looking for. Let me get back here and actually check if the name contains the offset in the string table. Yeah, okay, so that's exactly what I'm looking for. Section, I don't know what is it, so -1. And now if sh type, like the section type, is equal to 3, that means that's my string table. So my string table is equal to 3. Now I'm making a mistake here on, so not this mistake. I'm making a mistake here on purpose, and my mistake here is that actually I'm not checking if this I'm not checking if this is minus oh wait, that was okay. I'm not checking if this is assigned already, because if it's already assigned and I have a second string table, things are a little weird. But again, as I said, I'm not really verifying if this is a correct executable, a correct out file, right? Okay, now I actually do have the names of the sections, so I'm going to see what I can do. What I need is I need a funny function, which is basically like print or like get C string. It gets the data, it gets the offset, and it grabs a C string, which is basically a 0 or null terminated string. Sorry. Yes, it's Python. Or Python, whatever. Cool. So now, while I need some iterators of I is not equal to 0, this is a string, right? So I need this. Then some output. Sorry for my typos. Okay. Perfect. So now, this is nasty. I shouldn't be doing it in such a way, but okay. There is a question. I don't see a question yet. Oh, you can use ESH-str index to check if it's a correct section. Yeah, sure. That's exactly what I'm writing now. So I need. No, I don't need an if. I want to write out the section name. So I want to write this, and I want to get like get C string, elf, and now the offset. And the offset, I know where I made a mistake. I made a mistake here. This should be offset, obviously. Okay. So get C string, elf. So yeah. Okay, I'm sorry, I'm making like writing really nasty code. Struct isn't a module for me because I actually used this. I used from struct import blah blah blah, which means that struct is not a label I'm using in the global space, so I can use it as a name of a variable. I realize this might be confusing, so I'm going to change it to s, and this should be fine now. But it was okay. Yeah, this is just like a style change basically. A correct style change to do, though. Perfect. So now I do still have this, which is the. Oh wait, I know what this meant. He meant that he didn't. He meant that I can check here if a star section is actually equal to this. If it's not, then like. Okay, I guess I'm introducing some checking after all. Maybe I should like import assert or something, whatever. Okay, and now I need the offset in the file where are the strings. So assert tab offset is going to be sections of assert tab section offset. I know, I'm doing it in an incorrect way. I should do it differently. So I don't have to write this here because Python scoping actually allows me to like just declare a variable here, and it will be still visible outside of this block. But I do have this habit from like C++ that I do declare variables that I want to use outside of a block, I declare them outside of a block, which isn't needed in Python, again, because Python scoping works differently, but it's still correct, like as in it will work and it will be fine. I need to put the offset here, basically. So let me put it here. S is reserved for socket. Yeah, that's a fair point. So how do I get the offset of contains offset and bytes from the beginning of a section? Perfect. So now I have the offset. So the section name should be a C string. Add the str tab offset plus sh name. Let's see if it works. Yeah, it works. Perfect. I have section names here, as you can see. And like some sections are actually, like the 0 section is not used, so it doesn't have a name. My text section is here, so this is what I'm looking for. So, perfect. We can list sections, and now the real name of the section is this. And this is a part of a packer which is specific to today's episode, and probably normally should not be done like this. But as I said, I'm going to explicitly pack a section which is named text. Text obviously is not text, it's code, but for some reason in executables you called the code section text. One exception is the Borland compiler. The Borland compiler actually uses code, like capital letters code for this. So if this is it, then the text section is I. And I do have the text section now. Now what do I need from the text section? I do need from the text section a couple of things. First thing I need is text offset. And the second thing is text size. Again, I do not need to write this variable label initialization here. I could do it here, but it's a habit I have, which I believe is, it's okay. It's okay because it makes the code more readable. Offset, this is easy, is sh offset. Now, the size I'm interested in is the size in the file. The size in the file and the size in the memory are two different sizes. So I need to be sure that sh size is actually the size in the file. Yeah, it is. I don't know, can you see it? It's in the file. In the file, this word here is really important. Okay, cool. So sh size. I can like write a happy message here. Text section at of size bytes. Okay. My apologies. This looks more or less correctly. I'm going to double check if this is correct in IDA, obviously. So let's jump to IDA. Let's open this window again, and we have 3BO. This is obviously, this 3BO is not in file. This is in memory. So I'm going to jump to it. And here at the bottom, this is the file offset. And the file offset is, you can probably see it, 3BO as well. So, yeah. This is correct, at least. Now let's look at the size. The size of the section, I don't really see it here, the size in the file, but I can calculate the size in the memory and check if it's somewhat similar. So it's like 3BO here and A0684 here, so that's, I'm not going to even pretend I can do it in memory. I am going to do it in Python. OX A0684 minus OX3BO. I totally skipped like the 4 at the beginning because I don't care. And this is the size, which is looks somewhat similar, right? So this versus this is actually identical in the file and in the memory, which is somewhat weird, but yeah, usually in the file it's smaller, because in the memory, but what I'm saying now is specific to the portable executable format. Usually in the memory it's aligned to, the section is aligned to the whole page, not always, but usually, and in the file it's actually smaller because it's aligned to like 512 bytes or something. So okay, we do have already the entry point, we do have the text section. Now we can basically encrypt the text section. So to do this, do I need it? What is this? No, I don't need it. I don't need this either. To do this, I'm going to create like something called new. Is new a keyword in Python? I don't think it's new. Maybe packed. It's packed. Packed isn't a keyword in Python. Good. And this is going to be a byte array of elf. So I'm basically making the copy of the string elf into a new byte array, because I can. The byte array is modifiable, is mutable, while the string isn't, and I do want to mutate it. And I'm at the same time I'm basically keeping a fresh, unchanged copy of the elf file in memory. So yeah. Encrypt with, as you can see, with quotes, basically with quotes, because this isn't real encryption. This is, well, XOR isn't real encryption, but that's not what I mean. What I mean is that, again, it's obfuscation, because the key for decryption has to be in the stub, in the shell code, which is basically run at the beginning to decrypt it. It has to be there. It has to be there, or it has to be derived from there, because there's something called, like a technique called the time lock, which basically says not to include the key in the loader, in the loading stub. So the shell code at the beginning is usually called the loader. Instead, you, for example, if the decryption key is like 8 bytes, you have 6 bytes in the file with 2 bytes missing, and you have like some MD5 of correctly decoded, decrypted text section, or like the whatever section there, and then you just brute force it, because like missing 2 bytes is just 64,000 tries, 65,000 tries, and so you just try one by one, and you compare the MD5 of the decoded section with the correct MD5, and once you hit it, you know it's correct. And why do you create a time lock like that? It's actually like super fast when you just launch it, but that's what malware does when it tries to evade antivirus, which waits for the malware to unpack in memory before scanning it, like in a universal way, in a generic way. It basically, because emulators, at least in the older days, I'm not sure how was the state now, because the emulators and the antivirus would run, for example, 1 million cycles of the executable before scanning the memory and seeing if there are any signatures of malware there, and therefore the time lock would basically take, for example, of 10 billion cycles, right? Which is, again, like, I don't know, 2 seconds on the 2.5 seconds on the PC or something. But in an emulator, the emulator would just give up and wouldn't find a signature. So that's why time locks were used, and that's why there are cases where you put just part of the decryption key there. But it's not meant to stop the executable from being unpacked. It is just like a different form of obfuscation, I would say. Okay. Cool. So encryption, right? So for I in range, and it's Python 2, but I guess I should use X range here, because the range is going to probably be larger. But I think in the newer version of Python 2, it's actually X range and range are similar. Let's try. Let's see if I can, like, how much RAM I can allocate them. I'm actually quite curious. Range and a huge number here. Let's go for 64. Because range normally in older Pythons return the list. Let's see if I can allocate a list of 32 gigabytes. No, 256 gigabytes. If my stream dies, I apologize for that. Has too many items. Oh. So maybe it does return a list still. Yeah, because so I'm confused because I actually read the Python code for range and it does has some optimization there, but I don't remember which version I did use for. I know that in Python 3 is an iterator, but in Python 2 there is some optimization there as well. What's the type for returned range? List. No, it's list, so maybe I'm mistaking. Maybe I was looking at Python 3 after all. Yeah, so I'm going to use xrange here, where xrange is actually you know, an iterator, right? So it doesn't allocate a list of like 1 billion elements instead of just a simple iterator. I could probably use an like xrange here as well, but like for like 32, it hardly matters. But I guess it's a good habit to have. Now, the size of the section is what I am iterating over. Now, in the packed offset of the text section, so no, sorry, this is a mistake. This should be text size. Text offset plus I XOR everything with a magical randomly chosen number of I5. I don't know if you know why A5 is like a commonly, or like 5 or AA, why is it a commonly chosen pattern or number in such cases, is because if you look at it from a binary perspective, it's actually like 1010 or 0101, so it's basically the same amounts of zeros and ones evenly spread across the number. So that's why like usually 5A or A5 you see in like random crypto related situations where it doesn't matter what the number should be random, but it should be somewhat mix the bits when XORing, for example. Okay, with big ranges, just use while. That's what their supervisor said. Why? So why do you think it's better? Is like actually adding faster than using an iterator? It's a good question. If you know, just let me know. Okay, so we're encrypting it now, and in the end we have an encrypted executable, and we're writing it here, but we should actually do packed here, and this is my to-do. I wonder if it will work, or if I have to actually convert it to a string. One way to find out, and that is by running the application. Now, this file was created, obviously, so I'm going to compare these files binary, in a binary way using total commander to see where it actually changed. And it changed starting from this offset. I guess there are like... yeah, this looks okay. Let's see if it changed a lot of stuff. Like enough stuff. It stopped changes around here, which is kind of the correct place where it should stop the changes, I guess. If not, we'll get to it later. I'm going to show you the file in IDA now. The file doesn't work, obviously, but I still am going to show you it in IDA now. So let me open it in IDA. Yeah. So now it looks like this, which is obviously like the start point. This looks nothing like what we saw before. Like, what is it? But it's not yet in the final form. But already the code is obfuscated, right? Doesn't work yet because I still need to add my loader, my shell code at the beginning. Which brings us to the funny question of where do I actually add my shell code, right? Yeah, and this is where things get funny, because the normal way to do it is to actually add another segment, like, or another section at the beginning called something like, I don't know, dot packer or dot like pack or something, right? And yeah, and you have it like readable executable, and there is your code there. There's a question from HonoraryBot. Do you actually... Oh, hey HonoraryBot. Do I actually analyze malware on a regular basis? Not anymore. I used to do it in my previous company, but that was, again, 10 to 7 years ago. So yeah, not anymore. Anyway, given this, we do have... yeah, this is the correct way to do it. but I'm not going to do it this way because I have 20 minutes left. What I am going to do, I'm going to probably inject my code in some place where we have a lot of space. Well, just a lot of space is not the correct word. We have some space to inject my code. And again, usually in a packer, oh sorry, there are some questions, so, oh yeah, I answered already this one. Just tested Python 2, xrange was less than half of time for a while. Thanks Dohan for testing it, that means that, but yeah, that xrange is faster in the end after all. Anyway, so to, so yeah, but since I have 20 minutes left and I would like to show you folks that it's actually running, I am going to cheat a little and find a place in the executable that is not really used where I can place my code, that where my code basically will just like well do what it has to do and move forward. Now I guess I can see, oops, already some space here due to alignment. And at the like text section ends at 684 and this starts at 690. That actually means that there is like OC bytes there. OC bytes is not enough, but maybe at the end of the text section there is some place or some unused function which I can override. Again, normally you would add a new section or a new segment even for your code, or what's even more probably, you would extend the last section or segment, make it executable, and right there. Okay, so I was actually going to go at the end of the text section, so we are here. There is some funny function here, and some other function here, and these might be super important functions for the program. I have no idea if that's the truth. I am going to test it though by overwriting it. So I am going to comment out this encryption, and I'm just going to overwrite it with like CC and see if it's executed at all. Because again, I'm testing it on just one application, I can do cheats like that. So let's go at the end, and let's assume I think I need like around 256 bytes at most, so I'll go to this address. Let's assume here it's a little less than 256, but it should be fine anyway. So starting from this offset in the file, A0584, so that's EO bytes if I'm counting correctly, and that's A0584 plus I, obviously. I'm going to just write CC there, CC being obviously like int3, which is the breakpoint, so it will crash, it will just crash. And no, it is close to, it is actually 100 bytes. I thought I had a different offset here, so my bad. 100 hexadecimal, which is of course 256. Okay, so I'm going to run it again, run it, and now I should only have overwritten this final section. I am going to again check it. Here, yes, this is just my overwritten stuff with CCs, which is good, so I'm going to execute it and see if it crashes. No, not hello, sorry. Yes, hello, but hello.packed. Can you see something? You can see something, I guess, here. I'm going to make the console a little smaller though, so I'm positive you can see it. It didn't crash, which means I can write at this offset, I can put my code there, and I can change the entry point to actually point to this location. Again, this is not something you'd probably do in your normal executable, but it's like, I think, acceptable given the time constraints we have. And it does basically show the concept. That being said, since if you have any idea for the next stream, of what I should handle on the next stream, please put it in the comments down under this stream. And if it's, for example, making this packer or protector, more like do it properly by adding a new section or segment, you'd like me to continue working on it, then please let me know in the comments down below. Otherwise, I'm going to just choose a different topic, assuming that I am going to finish this today, and I think I am. Just the basic idea though. Cool, so now I need to add this offset. This is like magic offset. Jesus. Okay. I'm going to write my shellcode. What shellcode, you might ask? And the shellcode I'm going to write now, obviously. So I'm going to create a file called loader.nasm because I'm going to write it in NetWhite assembly, which is my dialect of choice, and 64 bytes, not bytes, bits. I'm going to assume that the offset, or the origin actually, is this with a 4 at the beginning. And I'm going to compile this. So I'm going to do OS system nasm loader. I cannot even type loader nasm. So I'm going to compile it. Once it's compiled, please note that I do not do any error checking here, which is incorrect, obviously. I'm going to do like just load it with open loader read binary as file. Loader is supposed to be a byte array of fread. Yeah. So now I have it loaded, and now I put my loader. Can I do it? Let's see if I can do it like this. Add the magical offset plus length of loader. I'm going to put the loader there. I think this should work. I think it actually is supported. And are there any questions? No questions. Perfect. The loader is there. Now I need to, after I'm going to write the loader in a second. Oh, there is a question actually. Why use subprocess check output? Because I'm lazy, but okay, let's do subprocess check output. The real reason is that I didn't want to scroll my screen up. Okay, and I actually need to change this then. No. Incorrect. Dohan, you do know that I do not write beautiful code on my streams due to time constraints. But it's, yes, this is the correct way to do it. Check output actually checks the exit code, and if the exit code is not 0, then it actually exits with an error the main, or throws an exception actually. And that's a great way to say it. Cool. Now, I need to change still this field. Entry, to point to my magical offset, right? Or actually magical virtual address in memory, because the entry point is not in the file, it's in the memory. Therefore, where is it? I need to count where is it. Count as in count the bytes there actually. So let me scroll it up. Here. 16 bytes, then 4 bytes here, this is another 4 bytes, so 8 bytes total, and then we have this, so it's 24 bytes from the beginning of a file. This is where our thing is so packed. 24 bytes, I know that it's actually 8 bits, so I do +8, and this is supposed to be equal to byte array of pack of 1 keyword. I'm using native endianness, as you can see here. And this is my new address, which is magical offset plus actually where it's loaded in memory, which is this. No, wait. This. 1, 2, 3, 4, 5. Yeah, this is correct now. And this should overwrite my the entry point. Am I counting this correctly? It's 4, 8, yeah, 24. Should be fine. Cool. So now I need just to create the loader, and instead of already writing the loader, I'm just going to do something like this. Jump, do an infinite loop, just to see if the replacement of the entry point works. And yeah, otherwise, if I don't check it now, then if something crashes, I will wonder whether it broke due to this line or whether it broke to my loader actually. So let's try it again, and I can actually do like this. Hello.packed. Yeah, it's in an infinite loop, which means it actually, no, it's a good signal that there is a chance that it jumped into my loader. So I need to verify it by changing the behavior to int3, and it should crash now. It did crash with a breakpoint trap. This is int3, which is a software debugger breakpoint, which is fine. This is the correct thing. So now I have confidence that it actually jumps here. Let's talk about polymorphism. Polymorphism is it's basically when a piece of malware uses so there are two things like polymorphism and metamorphism, but the idea is basically that each time you run a packer, it randomizes the packer's loader code, and also like the encryption keys and so on. Therefore, it's harder to, if you have two different malware samples, it's harder to actually analyze it because you have two different loader codes for both pieces or samples of malware, which makes it harder to create an automated tool to actually unpack them. That being said, when I was working for the antivirus company like 11 years ago, the static unpackers which we are working on were for polymorphic packers, and if you emulate some stuff and predict some stuff, then it's actually still pretty doable. I'm not saying it's easy, but yeah, but it's pretty doable. Writing a simple VM for protection. So the VM is the easy part. The hard part is actually translating the code you have into a VM. Okay, let's write the loader. So what does the loader has to do? It basically has to put on the stack the registers which I'm going to change, right? And then unpack, and then actually call mprotect, because I have to change the text section to be writable, because it's not writable in memory now when I execute it. Then change it, and then change it to be executable again. That being said, if I do my trick, which is actually placing my code at the end of a text section, and I have like this kind of protection in the kernel, which basically means that, WXOR-X. WXOR-X is when you, the page in memory can never be both writable and executable. That means I have a problem, because my code, which is supposed to be executable, cannot execute because I just set the text section to be writable. So yeah, but it's not. I do not have this protection enabled on this virtual machine I'm using, so that should be fine. Okay, cool. So yeah, I don't know what registers I'm going to push on the stack yet. I will start with this just to have some boilerplate code here. Now, starting from, oh no, now I need to do mprotect. So Linux 64-bit. Syscall. Okay. Yeah. It seems it thinks I'm a bot. Perfect. I'm not a bot. Oh, good. I like that it was confirmed, like, publicly. Or I'm a very good bot. Mprotect. Here we go. What do we need to do? We need to... What are the registers? So it's RDI, RSA, RDX, and I don't know if I need anything else in mprotect. No, I don't. Cool, and racks, obviously. So, to racks we move 10. It's normal 10, it's decimal 10. To RDX we move the flags. I don't know what the flags are, I will put them here in a second. To RSA I move the size, and the size of the text section, I'm going to hard-code it here, and normally in a loader you wouldn't hard-code it. So what's the size of the text section? The size of the text section is 3BO, and so we start at 3BO, and we actually end at our loader, because we don't want to, you know, overwrite our loader, right? And our loader is magic offset, so it's this. And this is where our loader actually begins. So this is the size, but the size needs to be also aligned to a page. I don't think it has to be, but it can be. So if I want to align it to the page, I just basically OR it with this, and this will align it to a page. Now, RDA, will it align it to a page? No, I have to still add 1 to this. Yeah. Now it will align it to a page, in this case. Or I could just, you know, do this, and this will work as well. Now, RDI is the address in memory where I have it, and the address of memory where I have it is actually really simple, because this is the address in memory where I have it. Again, I'm hard coding this. Normally in a packer you do need to read them from the file and put it here programmatically, but I'm not going to do this now. If you do it programmatically, you would actually have to put some magic value here, like ABCD 1 2 3 4 or whatever else, and find this magic value and substitute it with whatever the value is that you have to put there. Okay, this is fine. Now I need the flags. Man and protect. And the flags are called prot write, read, executable. So I look for it in user include. And is this it? No, it's not it. Any day now. Here we go. This file has it. And, well, yeah, no surprise, totally no surprise, we just put 7, and that means readable, writable, and executable. 7 arrayX, and now we do a syscall. And after returning, we actually should have our range of memory to be writable, right? So now we put in some register, one of the already changed registers, I guess, the address of the start of the section. Again, I'm going to hard code it, right? And it's actually like this. 3BO. Going to check an IDA. Okay. Sorry. Then the size of the section, and the size of the section is actually exactly the thing I calculated here. Where's my calculation? Here we go. And somewhere I need to put the key 5A or A5 actually. Now this is RDA. I want the same value in RSA. Okay, and now I can use, you know, like what was it called? Loads byte. Load a byte. It actually loads a byte from here, from this offset, and puts it in, where does it put it? In AL, right? So I need to change this. Oh, I actually don't care. I'm going to do AL A5, and now I need to store it, stores B. So yeah, this instruction basically grabs a byte from here, but increments also this register. I probably should do like CLD somewhere here, which is clear direction flag, though I think it's pretty much guaranteed that the direction flag is cleared at this point. And this does the same, sorry, not RDI, RSI, obviously. Stores B is basically store byte at the RDI register, destination index, that's why the register is called the destination index, and increment it as well. So this is basically a nice loop, and since it's a loop, I can do like my loop. Well, okay, let's just call it decrypt. I'm going to loop to decrypt. Now, loop is an instruction which actually decrements ACX and checks if it's not 0, and if it's not, then jumps, or the other way around, something like that. But it will repeat this RCX times. So this is fine. I am going to clear the direction flag here after all. And now I just need to see which registers I changed. So I changed RDI, I changed RSI, I changed RDX, and I changed... did I change anything else? RCX. And now in the reverse order I do need to actually... in the reverse order I said, so pop RCX, pop RDX, pop RSI, pop RDI. Not like this. RDI, RSI, RDX, RCX, okay, this is fine. And now in the end I do have to jump to the original entry point. Now, again, I should probably put the original entry point here in some like in a proper way, right? As in programmatically from the Python script. I am not going to do it today due to time constraints. I'm just going to hard code it. FreezeX says that it first decrements and then checks. Okay, yeah, that makes more sense. So I'm going to push it and I'm going to return to this address, which is basically a way to jump to an immediate value. This actually even has a chance to work. Let's see. So I'm going to... I'm actually, as you can see, I'm not returning the correct permissions to the memory for it to be only like readable and executable. A proper packer should do it. For example, if I remember correctly, UPX doesn't do it, which makes some stuff easier to exploit, which is quite funny. But yeah, that's how packers work. Okay, pack it and then run it. Sorry, I do believe I have this. Yeah, and it works. So it seems my protector actually worked. Okay, I think the comment from FreezeX appeared here as well, so I'm going to leave it for a second. I am going to now open this this file in IDA to see if it actually did it really work, or did I forget to like call the proper file or something, right? So let's do this. Okay. So we start here. Where is here? Here is where we are supposed to start. This is our magic offset, which I've chosen. And this is the code which I just written, so you should be really familiar with it since you just saw it a second ago. And in the end, it should jump here. So if we jump here, obviously there is no proper code here. So what I'm going to do now is I'm going to actually test it in GDB. Well, this also means that in IDA, until I actually decrypt this stuff, I don't really know what's going on here. I cannot analyze this code, so the protector kinda works. It's super easy, obviously, but it kinda works, right? So, let's run it in GDB. Let's see if GDB complains. It shouldn't complain, actually. Okay, and let's break at the entry point, which is... Sorry, what was the entry point? I actually don't care about breaking here because it first needs to decrypt. So let's maybe let's just break here. Okay, and run. And it broke. It broke as it hit the breakpoint. And where is the code I'm looking at? This is the code I'm looking at. So now I'm going to look at the code in the text section, at the beginning of the text section. No, actually at the original entry point. So this here. So this, no, this is X. I really don't see it, what I'm typing, my mistake. This offset, it's hardly our instructions. Yeah, this is the incorrect code, and now I'm going to like single step a couple of instructions of the loop, which is decoding, and I'm going to do it again, and for some reason it's still the same stuff. Why is it the same stuff? Oh, right, because this is actually this is farther down the right line. It's not at the beginning of a section. Therefore, I'm just going to put another breakpoint at this return address. Yeah, continue. It should be decrypted now, so I can dump it in memory. And as you can see, this is like a normal prologue of a function. So this is this is the decrypted code at the same address which I was looking for in a second ago. And maps, how do you do maps? Like info maps, proc info, yeah, not proc, I don't remember. Yeah, let's do like the old school way. This doesn't show what I want to show. I want to actually show the proper procs maps. Yeah. Okay, here we go. And as you can see, this whole section of memory is actually writable and executable now because we changed it. So this isn't a great idea from a security perspective, and I mean, like, you know, like normal low-level buffer overflow style security, because it's easier to exploit. And as I said, some packers do it, but usually you should clean up after yourself. So you should actually set the proper rights to all the sections after you're done unpacking them. But again, I'm not going to do it today. Info proc map, no, VM map, perfect. Oh, look, it even like underlined the section, which has really too permissive stuff. So I guess this is it for today. 1.5 hour hit just like 5 minutes ago, so we're on time, surprisingly. Are there any questions? I am going to upload this code to GitHub unless I forget. If I forget, then just ping me. Yep. So that's that. Do you have any questions to what happened here today? If not, then we meet again next week for... There is no Polish stream tomorrow because I'm actually out, so sorry about that if you were waiting for it. Are there any questions? If there are any questions, let's, I guess, like, wait a couple of minutes. If no, then I will finish the stream and we can round it up for today. Are there any good resources how to do this for PE files? Or is it kind of the same way? It's exactly the same way. It's like the names of the fields are different, but you do it in the same way. There is a nasty thing that the import section usually is in the, not usually, sometimes is in the text section as well at the end of it. And this sometimes complicates stuff because your import section will be totally destroyed by your encryption, right? But apart from that, is rather similar and rather easy, I would say. Okay. If packers usually clean up, can't you see what sections and when is encrypted just by watching permission change? Yes, you can. That's totally a good point. There are actually like several documented way, I would say, or known tricks where you can catch a loader after loading the file, but before executing the original entry point, and like breakpoints on like virtual protect on Windows or on the mprotect syscall on Linux is one of them, or the aforementioned trick with doing a breakpoint on the stack at the like because you can see, sorry, you can see even here, right, in my code that I do this. So what you do is you basically allow this instruction to execute, and then you have this racks on the stack, and you do a memory breakpoint on it. And when it returns, and it will return here, well, when doing this, you're just before jumping to the original entry point. So doing a memory breakpoint on this item on the stack is another common idea. Then I remember there are some ideas on actually looking at what places in memory are touched. If you see like a whole sequential writes to the text section and then to other sections when the other sections are being decrypted, and then suddenly a stop and like some very random different memory patterns, that usually means that that between these two different patterns it stopped decrypting at some point. So like you can basically at the end of a sequential pattern you can stop breakpoint and dump the content just before reaching the original entry point. So yeah, there are basically several ways to do it without even knowing how exactly the protector works. If you do analyze the protector itself, then you basically get to exactly know what it's doing, and after analysis you know exactly how to counteract it. Obviously the analysis might take several hours or days, right, depending on the complexity of it. So Adrian says that look for push AD and pop AD. That being said, on 64 bits, if I remember correctly, there is no longer push AD or pop AD, unless I'm mistaken, obviously. UPX is, by the way, one of the most commonly used packers. Its main purpose is not protecting the executable from reverse engineering. It doesn't have any anti-debugger tricks or anything like that in the loader. Usually you basically put all of the tricks you know in the loader to detect the debuggers or something. But UPX is basically just to compress the executable, and it works for I don't know, every executable format out there. Is just amazing. And yeah, actually a good homework is go to the pack your program with UPX and analyze it later on. Analyze the packer, try to reverse engineer it. It's don't go into the decompression routine, but analyze everything else. The decompression routine is rather hardcore, but everything else is pretty readable, I would say. Yeah, it's called the ultimate packer for executables, and seriously, it totally, I think, supports all of the executable entries out there, formats out there. Is there somewhere a list, perhaps? There's Wikipedia entry. Therefore, I guess this is for example, Atari format for some reason. Maho, obviously, PlayStation. Vatcom LE. Vatcom LE was something which was used in old DOS games, which jumped into 32-bit protected mode for some reason, for obvious reasons. Okay, so given that there are no more questions, thank you very much for being here today, and see you next week. If you have any questions at any time, just put them in the comment or send me an email. I'll try to reply. I cannot promise anything because I actually get quite a lot of emails, so I'm usually lagging behind. So that's it. Thank you to KrzaQ for being my moderator today, and yeah, happy hacking. See you next week, and I'm going to leave you as always with some music. Yeah, and no mission today, sadly. Bye bye. Bye bye.